Hello everyone and welcome to this evening's webinar in our Eco-retrofit for Householders series. This one is on insulation, and I'm really pleased to welcome back our speaker Richard Shears, who works for the Retrofit Hub in Manchester. I'll do a quick 10 minutes of intro to start with, and then I'll hand over to Richard for about 40 minutes where he'll tell us, covering the broad topic of insulation. Then we'll have about half an hour for a Q&A. So do think up your questions, drop them into the Q&A if you want to. And then we'll have a poll and a wrap up for 10 minutes at the very end. So for those who don't know about Cumbria Action for Sustainability, or CAFS, we're working towards a zero carbon Cumbria. We have a lot of different projects. Do go to our website and have a look if you're not already familiar with us. We've also got on our website a lovely gift shop, and now we've got 4 special Christmas gift cards. So if you're interested in those, do take a look. In terms of what CAFS does, on the energy services side of things, we have free services and paid for services. So you may have heard of our Cold to Cosy Homes Cumbria for people who are eligible for advice, and for our paid services where we do in-depth energy advice and a whole house energy model and a report. And of course we do courses and webinars like this one, and some of our free services are funded by Energy Redress, but some of our work is obviously paid for services such as the Home Retrofit Planner. Saying a little bit more about Cold to Cosy Homes, this is for people who are eligible for help, and the eligibility criteria are quite broad, so don't assume you're not eligible. Do have a look, and it offers all those things that are listed there, but also now starting to include retrofit. So if you're looking at retrofit measures and insulation and so on through government schemes, and you think you might be eligible for that, then do take a look at that. On our paid for services side, so this is for people who've perhaps got an ambitious retrofit in mind. We start by modelling your home, we calculate the carbon footprint, we look at your priorities and what you're wanting to achieve in terms of comfort, health, air quality and so on. And that's our main Home Retrofit Planner report that we start with, and then we're building further services through a pilot at the moment. Some of you may be here because you attended some of our Retrofit Made Easy face-to-face events across different parts of Cumbria. And we've got more in-person events coming in January and February. So do have a look at the CAFS website events page. They're already up there. And we're in those communities offering free thermal camera surveys by volunteers. And the communities that we're helping there are listed just here, Ambleside, Keswick and so on. And so if you're in one of those communities, you can potentially book a free survey. And we've also got our Solar Made Easy project, which again, if you're anywhere in Cumbria, you can get independent advice through our Solar Made Easy scheme and quotes to local vetted installers. So do go and look for that as well if that might be of interest. So to introduce Richard, Richard has been working in the retrofit sector for about 10 years, and he carries out quite a wide range of activities from initial assessment of buildings through to installing the measures, him and his team at Retrofit Hub, and then uses his knowledge of all aspects of retrofit to help people navigate the range of options available. And I think we'll get a sense from today's talk just how complicated some of those things can be, some of the considerations are. But Richard's not only got the theoretical knowledge, but he's got the hands-on knowledge. He's working with a team every day who are doing this in homes in Manchester. So delighted to hand over to Richard now. Yeah, I'll be really keen to see what you're telling us. Thank you, Richard.
Thanks very much. Let me just share my okay. Okay. Yeah. So today it's quite a hefty subject. Talking about insulation. I know the last time I did it, I struggled to get through everything. So if I rattle through it today and I miss anything or you don't understand anything, put a question into the chat and we'll answer it at the end. So yeah, I work for the Retrofit Hub, or I founded the Retrofit Hub, but today I'm working on behalf of People Powered Retrofit, who's a non-for-profit service for householders in Greater Manchester. They offer clear, independent advice and support to help householders plan, procure and deliver their retrofit project to a high standard. They also offer contractor training, and they work with CAFs to deliver this series of webinars. So this is the third in the series, and I know a few of you will have been to the first two, so I just thought we would start with a recap of what whole house retrofit is. So to me, it's the process of planning and implementing a whole house renovation with the aim of improving the energy efficiency of the property. So it's kind of root and branch change of the house if you do it a deep retrofit, insulation and windows, ventilation, basically everything. But all these different aspects can interact with each other. So I wondered if you wanted to put into the chat box maybe a few things that you think interact, which maybe have an effect on a different aspect. I'll give you a few seconds to do that.
One thing I would say is if anyone's having trouble putting a message in the chat, just go into the Q&A and we'll take them in there. So that's absolutely fine. Just drop them into the Q&A, put your comments in there, because we can see anything you might
Yeah,
say. So
that'd be
you've
helpful.
got,
I know Debbie's raised a hand, but I can't answer it at the minute because I'm sharing my screen. So
yeah, it's okay. I can pick that up. But I think we've had some trouble with the chat in previous webinars, and it's not been working right, even though we've set it up to work. So I think that might be the problem. But if hopefully you can get into the Q&A.
yeah, yeah, I can see that. So yeah, yeah, condensations are definitely one of the issues that can be caused by insulation or retrofit. Ventilation's key. Yeah. Okay. So this is a diagram created by the Sustainable Traditional Buildings Alliance, which you can find on the internet. You basically put in the measure that you're doing, and it will show you the different areas that it might affect. So as you can see from that diagram, it's a pretty complex process, and there needs to be a lot of consideration for all the different measures that you might possibly do. It's kind of it's a balancing act between the different priorities of making your house energy efficient, but also not damaging it or creating a bad air quality. The approach that we normally use is a fabric first approach, which effectively means doing the fabric measures first, or planning to do them first, and then adding the rest in afterwards. So adding in heating and lighting second, and ventilation, and then going for the eco bling, things like solar panels at the end. It's been the kind of the approach that most people take to retrofit in the 10 years that I've been doing it. But I'd say that more recently, now that the grid is a lot more decarbonized, it's maybe a softer approach, and that considerations of, say, the character of the house or the age of the property are also involved in that. And it may be that you have to jump to kind of ventilation or heating before you do the fabric. But yeah, that's all in the plan of the retrofit plan. So if you want to put some answers into the Q&A about why insulate, what is it that's important about insulation? It's something I've talked about a huge amount, and it's kind of, yeah, it's mainly my day-to-day topic of conversation is insulation, which I never thought it would be when I was in my 20s. Yeah. So yeah, energy efficiency is one of them, but things like the heat loss of the house, reducing the heat loss, reducing the heat demand, uh, reducing the peak heating demand, and overall comfort as well. These are all benefits that you get from insulating a house properly. So this diagram shows the effect that you can get from insulating. So the house on the left-hand side shows the different areas that heat is lost to a house. You can see that with this particular property, there's about a third of the heat is lost through the walls and about 20% through the floor. And the second property shows a model house post retrofit, and it shows you there the walls are now down to about 10% of the heat loss of the property. So it shows the massive effect you can get from good insulation. We work to standards, or we try to work to standards that we need to work to a target to prove that we've done it properly, and to show that we can make a building perform better. And when we model it, we model where the house is now and where we're hoping to get to. You can see that the average house is about 140 watts per, 140 kilowatts per hour per meter square per year. If you want to go to a really high target, you might try and go to passive house, which is 15 kilowatt hours per meter squared per year. I would say that you could probably make any house passive house, as long as you've got the time, the money, and the determination to do it. A more realistic target may be the ACB standards, either retrofit standard or the ACB standard. These are much more practical, achievable targets. You can see here some of the actual achievements of houses that have been done. So these are taken from Carbon Co-op's early work. They modelled the house before and found what the actual heat loss was for the pre-retrofit, and then they've obviously shown the modelled after and the actual. You can see the huge difference between the not only between the actual differences between before and afterwards, but also the model differences between modelled and actual. That a model is just a model, and it doesn't always reflect reality. Sometimes they're pretty good, and sometimes there can be quite a big discrepancy between them. So one of the key parameters is the peak heating demand, which is a way of describing the heat input required that a building requires in order to maintain a comfortable internal temperature on a cold winter day. So it can be either described as watts per degree Kelvin times the design temperature, or sometimes it's displayed as the watts by degrees Kelvin, and the design temperature is the difference between a nominal outside temperature and the temperature that you want the house internally to be. This diagram shows the differences in internal temperature. So Public Health England specify that houses shouldn't really be below 18 degrees, that you can end up with problems of mold and damp, respiratory diseases, and that ideally it should be between 21 and 18. Obviously, taking the peak heat demand from the slide before, the higher the temperature that your target is, the higher the peak heat demand will be, and that means that the more energy you need to put in, and the higher the cost will be. So the part of obviously a big part of why we insulate is to keep ourselves warm during the winter. The heat goes through the building fabric, and when you insulate it, you reduce conduction through the walls, but you also increase the surface temperature. When you increase the surface temperature, you lower the ability for mold to grow and lower the possibility of condensation, to kind of major problems in houses. But it's not the only aspect that we look at these days. A lot of increasingly we talk about its cooling effect as well. So during summer, we're increasingly needing well-insulated houses to reduce problems of overheating. When you're thinking about planning your retrofit, it's not just about the insulation side of things, it's also about glass, the amount of glass, the placing of glass, the type of insulation you might use. If you use more natural materials or dense materials, then you get a benefit called decrement delay, which is the slowing of the heat going through the property. Yeah, and then there's obviously the issues of building services going through the insulation, or the increased need for ventilation. If you really highly insulate a house and make it airtight, then ventilation becomes a much more important aspect. So I'm just going to go through the insulation approaches and materials in this next section. So this slide shows the difference between a more modern house and a more historic house. We class traditional houses as those being built prior to in the 1920s. Some say 1930s, some say 1919, 1920. But basically there was a difference in construction type around that time, that before it was built with traditional materials, so bricks and lime mortar. There was lots of, it was heated by fire, so there's lots of ventilation and infiltration. And after the 1930-ish, we changed the way we build things. We used a lot more cement, a lot more industrially manufactured bricks. The processes were more industrial, so it's a lot less breathable. I'm not particularly like that term, but everyone seems to understand it. Post 1930, it's less breathable, but pre 1930, much more breathable. There's more vapor diffusion going through the fabric. So going to go through the different elements of a building. Obviously, we have walls. I'll go through floors and roofs at some point, but let's start with the walls. That pre-1930, a lot of properties were solid wall. Like I say, solid wall, breathable, vapor permeable. We used fires a lot to heat them, so the heat often pushed the moisture out. It wasn't so it wasn't so important to have it insulated because we had sort of roaring fires going. Post 1930, the construction changed to it was much more common to have cavity walls, and the heating system started changing to central heating, which heats the air, and so it's more important to have a more airtight building, and it doesn't really suit the way our houses were built, which is kind of where we've got to now, where we need to retrofit. We can insulate cavity walls. They weren't meant to be insulated originally. They were meant to they were actually first created on the coast to try and create some barrier between the inside space and the outside space. So you'd have the air gap, which would stop moisture getting through. That's a good question. I'll come to that in a minute. I'll come to that in a minute. But then from about 1980s onwards, we started filling them, and initially it was within it was with mineral fiber. It was kind of mineral wool in small pieces that was blown in. That does have a problem with wicking water, that it can slump, and it can cause damp patches at the base of the wall, which basically the water will hit the outside skin, clump into the insulation at the bottom, and then go through internally. We changed to polystyrene beads maybe 10, 15 years ago, which are better at that. Still not amazing. The problem with that was that they were again blown in, and they just kind of, if you ever opened up the cavity, they'd all come pouring out. There's been a few houses where I've gone into where there's been holes in the cellar that are just, there's just piles of the stuff in the bottom where they've not closed them up. The most recent development with cavity wall is adding a small amount of glue into the mix, so when it gets blown in, it sticks in place. And these are much better at not wicking the moisture through from outside to inside. It's still a risky measure, that you still need to be careful, make sure it's done properly, and that there is a clear cavity to do it in. There can be issues with what's called snots on the inside of walls, there where the mortar's not cleaned off, and it can mean you get voids in it. So it's often good to get a professional survey prior to getting it done. This can be combined with EWI to get a really low U value on the walls, so you're not stuck at just having to fill the cavity. You can put EWI with it as well. With most of you being in Cumbria, I think it's important to note that exposure and the location of where your house is a really important factor. An important factor, that if you get wind-driven rain or it's highly exposed, it can cause a lot of water to go into that outer skin and cross and make the insulation damp. So it needs careful thought. There's a few people asking what EWI. Okay, Tina will answer that shortly. Yeah, so just be extra careful if you are somewhere that's exposed. That cavity wall can be a risky solution. So EWI, external wall insulation. So the picture here is of a wood fiber installation, and it's in traditional buildings, it's a preferred method. It keeps it breathable, and is more sympathetic to the building. We also use EPS, which is kind of the second choice, I'd say. We use a lot in Manchester, mainly because a lot of the houses we do aren't so it's not so important to keep the breathability on the outside. But we try and steer clear of other materials. The things like PIR or phenolic on outside walls, I'm not so keen on that, especially if you've got traditional buildings. Then I'd certainly recommend using a more breathable material. It performs better than IWI and internal wall insulation, and you have a range of options for finishing it as well. It doesn't have to be rendered, it can be clad, and there are also brick slips that kind of imitate a brick wall, or you can tile, so you have more options with the look and aesthetic of the installation. The detailing is a really important aspect of it. I don't know if you can see the detail of this picture here, that there's this big red stripe down the edge of the building is where there's been a lamppost, And instead of thinking of a detail to mitigate the lamppost, the installers have just left a big gap up the back. So there's going to be an awful thermal bridge internally and a potential for condensation and mold. And a kind of a huge reduction in performance of the actual element as well. External installation has the added issues of planning permission, and more recently, building control are much more nervous about fire risks. So if you're going to be using wood fiber or combustible material, or potentially combustible, yeah, there'll be more conditions about where you can put the external wall insulation. So it's definitely worth checking with building control and planning permission before you start. An alternative to external wall insulation is internal wall insulation, which, as you might guess, is put on the inside of a room. As I alluded to earlier, it's not quite as effective as external wall insulation. You end up with more thermal bridges, and you maybe can't go as thick internally as you can externally. So you are limited on the performance you can get with it. And again, I'd also say it's more risky than external wall insulation. You're effectively cooling the wall down on the outside of the house and not allowing any of the heat internally to get to it. So you can open yourself up to problems with damp or condensation. And certainly the method that you use to install the insulation internally needs to be much more suitable to the property that you're doing. If it's traditional, then you definitely need to keep it breathable. Certainly need to use vapor open products, things like cork or wood fiber, things like insulated plasters like diathanite. And I'd certainly, if it's traditional, I'd certainly stay away from the foam backed plaster boards. They're vapor impermeable, and the methods that they're recommended putting on can cause issues as well. That ideally you want to be adhering the boards directly to the walls. You don't want to be leaving an air gap behind it. You can see on the picture here they've used a loft roll in between battens, which I think those battens are insulated, which I've seen used. It's not something I would use. I'd prefer to stay away from it. I think it's better to use an insulation board rather than this method. So yeah, there are some added considerations with internal wall insulation is, like I said, there, moisture movement through the wall, air tightness, it's really key. Making sure you detail it correctly at the base and at the ceiling height or past ceiling height. If you're going to do kind of a ground floor and a first floor, make sure you take the insulation all the way up through and don't leave that air gap in between the two rooms. Think about, it says at the bottom there, hanging pictures, but think about what's going to be happening in the room afterwards. Is it a kitchen? Do you want wall units? Is it a bathroom? Is there going to be a shower on the wall? Or you really need to plan these things before you start, because once you get the insulation on the walls, it's kind of it's a little bit difficult to go back and start again. This is a typical method that we use in Manchester, that planning are quite happy for us to insulate externally down the side and to the rear of a property, but quite often they're not so happy to do it at the front so we keep the character of the property. So on this one, you can see the rendered block down the side, and internally on the front, they've done it internal wall insulation. So you still get the same wrap around it effect, but it's just done in two different ways. When you do it like this, then the junction between the internal and external is where you need to think and make sure you get a good design detail to make sure you don't get any problems with condensation. So loft insulation, it's fairly straightforward. Majority of people know about it, even if there's still about 30% of lofts that haven't even been done yet, which is a kind of astounding given the amount of government grants we've had over the years. This is just a case of rolling loft rolls out into the loft. It's pretty much a DIY job, although you can get people out to do it. There's just, I think the main considerations with this would be air tightness and around lights, that sort of thing, around the hatch, and also at the junction between the loft and the wall at the front, because quite often there's not a lot of space to get any insulation in. With more traditional houses, you might have attics or loft rooms, which are more tricky to do. More often than not, it needs a different strategy. Again, in my opinion, it's keeping it breathable, trying to find a dense insulation like wood fiber so you can take advantage of that decrement delay effect, which in summer when you've got the sun beating down and the rooms are heating up, the dense insulation will slow that heat getting through, which does sound like that's what insulation is meant to do. But if it's a foam back board, then although they do slow the heat down, they also they don't retain heat and they don't kind of have that delaying effect. So yeah, lofts and in roofs, so condensation is quite often an issue, especially if you've got a loft space that's unheated. That quite often it's where if the hatch isn't very good, or if you've got holes for pendants of light going for lights, then you end up with condensation in the roof. So although you can insulate it if to good effect, you need to make sure there's good airflow in those unheated spaces above. And yeah, taking care of cables, lighting, other obstacles like storage tanks. And I did mention loft rolls, which are a typical choice. You can also use things like sheep's wool these days, or flexible wood fiber insulation as well, if you want to go for a more natural material. Okay, floor insulation. So that's an interesting question. So mixing materials. It does seem like a waste to take out existing loft insulation, but I suggest that if you're thinking of adding extra insulation in, so if you've got say 100 mil of a typical loft roll and you want to put sheep's wool on top, or I don't know, I think I'll save that till the end. Tina, maybe we can answer that at the end. That's it. It's a bit complicated.
Yeah, I think good idea to save these to the end. So we'll have a batch of loft questions and so on and so on. But do keep your questions coming into the Q&A area.
Sure. So floor insulation. There's two main types of floor. There's solid floors and suspended timber, and they each have their own issues. I'd say it's the most risky element to insulate. You really need to be careful and to plan it properly. Really think about what you're going to do. You can traditional suspended timber floors were often where a lot of the fresh air would come into a house, and that if you close that off, I mean, in one way that's good because you're getting rid of drafts, but in the other instance, you're actually shutting off any of the ventilation that gets to the floor, and that if the floor beneath isn't well ventilated, then you can cause real problems with damp and rot of the timbers and of the subfloor. So yeah, taking care to get the details right. If you're going to do it, I would say make it airtight. So you make it airtight on the warm side, add a membrane underneath to lower wind wash, but ensure that your floors, the floor subfloor, is still getting a good amount of ventilation going to it. With a solid floor, the considerations and the risks are slightly different. Obviously, with floors being solid, you can't really add a huge amount on without having to change door heights or change a lot of the ground floor. You can dig out existing slabs and insulate underneath, which is a common way of dealing with floors, but both options are expensive and disruptive. And with a traditional building, depending on when the building was built, you may not have a huge amount of space underneath there. The foundations may not be very deep underneath the floor. It might be a traditional earth floor, where you don't get a huge amount of depth at all to it. And if that's the case, then you end up with underpinning issues, and yeah, it's disruptive and difficult. One option with solid floors is to insulate the perimeter. The physics of the floor, the way it heats up and cools down, are different for a solid floor than they are a suspended floor, and that by insulating the perimeter, either internally or externally, can have as good an effect as adding insulation on top of the floor. That's another method of doing it. Yeah, so I think I mentioned everything there. The subfloor ventilation is key. Getting a good condition check of the floor before you start is the best place to start. Maybe getting a damp survey, making sure there's no existing damp. And junctions with the wall is also a consideration, that if ultimately your plan is to do wall and floor insulation, that you need to be thinking about the junction between them. So bringing wall insulation down to the floor, and making sure it marries up with the floor insulation. And again, this will have an impact on air tightness. Materials. Now, I've talked a little bit about materials as we went, but I'll see if I can deal with it a bit more thoroughly here. So there are a range of materials to use. They all have their different characteristics and different advantages and disadvantages and considerations that you need to take care about. Obviously, I think the first one is probably the petrochemical versus non-petrochemical. A lot of the reasons why we're retrofitting is to try and reduce carbon emissions. And if we're using a petrochemical-based insulation to do that, how much are we actually reducing our carbon emissions by? Although the manufacturers will tell you that there is a benefit to doing it, I think from one of the government's own studies, they realised that the actual doing a house fully with petrochemical boards is only reduces the amount of carbon saved by a very small amount over the lifetime of the insulation. So I'd always suggest trying to use natural or sustainable materials first. Not always the easiest solution. Sometimes the benefit that petrochemicals or foam boards have is that their performance is much higher, so you don't need so much thickness. So I'll just run through a few of the different materials. Mineral wool. This includes about 25% recycled material. It's resistant to rot. It does rely on quarrying the material. Sometimes it has formaldehyde in it. It can be unpleasant to handle, and it loses its thermal so it increases its thermal conductivity when it's compacted or wet. Wood fiber, as mentioned, this is typically made from waste materials. It comes from renewable sources, it's recyclable, it sequesters CO2 during growth, and it's hygroscopic, but it can be difficult to source. We sometimes have problems. Phenolic is more often known as kingspan, and it's quite often the pink kingspan that you'll see. This is one of the better foam boards to use. It's got high compressive strength. It's got the best thermal performance of the different foam boards. It's not very good at handling moisture. It's not very recyclable, and it's made from a toxic petrochemical. And one of our main considerations why we don't use it is that it can shrink once it's been put in, and it also off gases. Similar to phenolic is PIR, which is, hope I get this right, polyisocyanurate, which is a polyurethane, and as you can guess by part of the name, it's made with cyanide. So yeah, not a particularly nice material. It doesn't handle moisture well. It does have good performance, not as good as phenolic, but it's still pretty good. And it's resistant to rot and vermin. Again, not keen on using this. I'll use it where we have to, but I'd prefer to try and keep away from it and take the hit on the performance as opposed to sticking this everywhere. These are so phenolic is used internally, externally, as is PIR. But the next two, EPS and XPS, they're mainly used externally. So EPS is expanded polystyrene, and that's the boards with the large beads in it that look like cavity beads, but they've been squashed together. And XPS is extruded polystyrene, and that's it's the same material, but the grains are far smaller, so it's a much more dense material. Again, high embodied energy, resistant to rot and vermin. It is recyclable. It's not good at handling moisture, and it can be hazardous to fire as well. One final material we could use is called aerogel, which is it was made for the shuttle, I think, to help it on re-entry. And somehow it's made it into buildings now. So it's got really good insulating properties. You can use, if you're tight for space, say around windows, you can use this to good effect. Yeah, you need a very thin amount to get the same amount for other materials. It's not great at handling moisture. And the reason why you might only want to use it around windows is because it's hideously expensive as well. So it's used sparingly, I think, is the best way to describe this. So there we go, pink phenolic. You can see that the aerogel on the bottom right, wood fiber on the bottom left, mineral wool top left, and EPS on the top right. And then this green stuff here, this is XPS. We use this as a plinth insulation at the base of external wall insulations because of its impermeability to moisture. So it's great if it's going to be in a wet environment. It really does stop that moisture getting through. Whereas even something like EPS might have a problem with damp if it's continually wet. Go on to windows and doors. Right. I realised I've done it again. I've not got through everything. So windows and doors. Windows and doors are the weak point of any retrofit. That they're the hardest to have it to insulate. They're the hardest to improve. So I'd say using triple glazed the windows, or the best windows you can afford, to try and limit the heat loss through doors and windows. So just as a quick recap, the main aspects that we should be looking at or planning when you do a whole house retrofit are the insulation, air tightness, always have an air tightness strategy, and then a ventilation strategy as well. These three kind of go hand in hand. So the next one's a knowledge check, but I'm actually going to skip through it so that and go on to the next section, which is about U values. And again, I'm probably going to try and skip through this pretty quickly. It's quite involved, quite technical. But basically the way that we model or measure buildings is by using U values. So all materials have a K value, which is its thermal conductivity. The higher the number, the more conductive the material is. And we use it as a way of comparing different materials. So you can see there that PIR is down at 0.022, whereas something like mineral wool or wood fibre is about 0.035, so about half as effective. So you'd need twice as much material to get to the same U value. A U value is the value of each material has its own U value, which is a combination of the conductivity and the thickness of the material. And each material is then added up through the whole assembly of the wall or of whatever to create the full U value for the assembly. So on this example, you've got the surface resistances internally and externally. You've got an internal plaster layer, the masonry wall, the external insulation, and the render, and all 4 or 5 of those layers build up to make the full U value. These are some of the targets that we aim for, or some of the nominal values that we have. So you might have say an uninsulated solid wall would have a U value of between 1.7 to 2.1. And once you add insulation to it, that would drop down to 0.3 or maybe 1.5 if you go really far. So you can see the difference in between different values for insulated and uninsulated walls. So this example, if a square meter of wall has a U value of 2 watts and the internal temperature is 20 degrees and the external temperature is 20, what is the rate of heat loss through the wall? Now, we haven't fully explained this before. So if I go to the next one, so the uninsulated wall has a U value of 1.8 and the internal temperature is 20 degrees and the external temperature is 0 degrees. Then what is the rate of heat loss through the wall? So it's effectively 1.8 times 20. And I've covered it over with my poll, so I can't quite see. The answer is, sorry, so it's a 10 meter square wall, has a U value of 1.8 with an internal temperature of 20. So that means that that wall has a heat loss of 360 watts. And that heat loss is for 1 second. So if you wanted to calculate that as a kilowatts per hour, you'd multiply that by sorry, if you've got the heat loss of 360 watts, if it's over 2 hours, then that's 720 watt hours. So that makes 0.72 kilowatt hours over that 2 hours. So that's an uninsulated wall. If we change that to an insulated wall and we reduce the U value of the wall to 0.3 watts meter squared per degree Kelvin, what will be the ultimate heat loss over those 2 hours? So when you insulate that wall, you then have 10 meter square area of wall externally insulated with a U value of 0.3, sorry. The internal temperature is still at 20 and external 0. So it reduces the loss through that wall to 60 watts. So it's a sixth of the heat is lost after insulating it than before. Sorry, there we go. So through 2 hours, the 60 watts over 2 hours is 120 watts or 0.12 kilowatt hours. So I've really rattled through that because I know I've run out of time. And it probably wasn't very helpful because it's quite an in-depth subject, the calculations of U values. This is a better way of describing it. I should have just skipped to this. So the uninsulated wall there is on the left with its U value of 1.8, and the insulated wall on the right is 0.12. So you can see the drop in heat loss through that wall because of the insulation. Floors and roofs are calculated slightly differently. It's far more complex. It's to do with the ratio of exposed floor to floor area. And I think we can probably skip that today. It's important to know that you do need to calculate it, but it's quite a different calculation. If you need to get the U value of a floor, going to a supplier of the floor insulation is probably the best way of doing it because they'll help you with that calculation. Windows, again, a different type of calculation. It's not just a straight U value. It's measured either through the frame or through the glazing. If you go to good passive house suppliers of windows, they'll give you all this information, whereas you might find other suppliers obfuscate a little bit. Doors are calculated the same as windows. So how much do you want me to kind of stop there, or because I've still got there's still a little bit about regulations and standards I think I should probably go through, or
Yeah, could you just sort of whiz through the key points at a high level then, perhaps? That'd be perfect. Yeah.
So building regulations, these are the approved documents that we work from. That it's probably I was going to say it's wise to familiarize yourself with, but it depends on how deep you want to go into the retrofit. If you're getting advice from people, then they will help you with this. But if you're planning on doing it on your own, then it's probably worth having a look through these approved documents. Part L is the most important for energy use, but obviously with all the considerations of retrofit, there's also moisture and ventilation and fire are all important considerations as well. You can work towards a standard, as I said earlier. So the ACB have a retrofit standard. Letty have released their retrofit guide as well, which is really helpful and actually probably a really good document to read. Yeah, there's a planning portal which can help you with planning issues in your local area, specific needs, or point you in the direction of someone who can answer questions for you. I'm going to skip thermal bridges and go to one aspect of a practical aspect is quality, that there can be quite a difference in quality between installers, and it can lead to performance gap. So you really need to be aware that there can be issues around performance. So you can see things like this where they should have planned moving the boiler flue, and instead they've just cut a hole around it, which is problematic for a number of reasons. Okay, so I've skipped thermal bridges, and maybe I shouldn't have done because now you've got to try and find some. So this is an external wall insulation. A thermal bridge is where the heat is insulation can't quite get to an area, and you end up with a heat being lost straight through the wall, so there's no insulation around it. And I think normally on this we ask if you can point out the thermal bridges, but I think I'll just for time I'll just do it. So the instead of in between the two doors is really difficult to insulate, so you end up with a huge thermal bridge on the party wall between them. And a typical aspect of EWI, they've left the insulation short without putting a plinth on, so you end up with a thermal bridge at the base as well. Yeah, God, I hate this photograph. This is terrible. So they've not done around the windows, they've not done around the bay, and they've not done along the roof either. So you end up with just thermal bridges everywhere. I almost wonder why on earth you'd bother doing above the window at that point, but they did. So this is where we come to the performance gap that if you model a house with with external wall insulation like this one here, you expect it all to be covered and you take the wall as being well insulated. But if it's not well insulated like this one, then you end up with a gap between the modeled value and the real one. And it's something that we're always trying to overcome and mitigate when we plan a retrofit, that you really want the model to show exactly what is going to happen afterwards. So to wrap up, sorry I've rattled through the last bit of that, but the main factors to consider are the performance, what are your targets, what are the standards you're going for, the practicality of your retrofit. Can you go passive, or do you need to be a bit more practical? What materials are you using? Sustainability, vapor permeability, and obviously as well, cost is a major important factor as well. If I'll leave the we have got some questions, but I'll leave that up so that you can see the different links for further advice.
That's great. Well, thank you so much, Richard. That is quite, as I think you can see, it's a big topic. It's an in-depth topic. And there are reasons why we have experts to give advice, aren't there, really? There are reasons why architects are often involved in designing retrofits, or why we might have moisture calculations carried out, or cold bridging calculations carried out, or why we might want to turn to people who've done this before and who know what they're doing. So we've got some really interesting questions, and we've got some time to go through them. And what I would say first of all is that some of these questions are very much asking about, what can I do for my house? And it might be very hard sitting here now to actually answer those questions in a specific or detailed way, because we haven't been to the house, we don't know much about the house, and really this is where somebody like Richard, who might have a lot of experience, might go and visit houses in Manchester and answer these kind of questions, or other people might go to an architect to get the design done. So I'm going to ask them to you, Richard, but don't feel just answer as you feel is appropriate, with all the additional caveats that you would add in. So we've got questions. I'll just put them in order, really, because we've got quite a few come in. 8 so far, so let's see how many we can get through. So the first question is about loft. Oh, you've already answered, or you touched on loft insulation. Can you mix materials with, for example, existing insulation and a more natural product? What might be the ways that you might think about that there?
Yeah, so it is difficult. I mean, ideally, you'd want to use one material through the whole the whole layer of the insulation. However, with loft insulation, the materials you'd use would probably be mineral wool that might be existing, and say sheep's wool. I think they would potentially be fine. But if you were thinking of putting in some sort of like uh, wood fiber or mix, yeah, if there were two very different materials, then I'd probably suggest just removing the original. If it's only kind of 100 mil and it's old or covered with rubbish anyway, then it's probably just easiest to get rid of it. I have tried recycling it. I don't think I've found anywhere that takes it yet, which is unfortunate.
I suppose maybe you could, if you've got mineral wool, you could, if it's good in a good state and you can get rid of the stuff that's dirty or dusty or not really going to work anymore, you could insulate a part of the loft with the existing stuff, double it up there, and
Yeah,
then put the rest of it with the new stuff. So that might be
yeah,
one way that you
yeah,
could
absolutely, yeah, yeah.
potentially make.
It's probably movable. Once it's down, it's fairly easy to pick up and move if you need to. Yeah.
Yeah. Next question. How is it best to insulate the inside surface of the outside wall in a space between the floors of a house? So this is something that actually people often forget to think about, but that's a really good question.
Yeah. So if we normally do it in the same material we're doing the internal wall insulation. So we try and stick to wood fiber. So we'd use a wood fiber in between the joists as well. We we often parge the wall, so you kind of cover the wall in a coat of um, the adhesive or the lime-based plaster, and then we do that between the joists as well. So and then tape them as well, so you make sure it's airtight. But yeah, you just use the same material as you're going to use for the internal wall insulation.
Yeah, and as we inevitably you're cutting through the floor, or you're cutting through the ceiling to get that little gap there to push the insulation up. Ideally,
Yeah,
you might actually have taken your ceilings down if you're doing other work as well. But it just depends really on the individual case to some extent.
yeah.
Yeah. Now another good one. What do you use for insulating the floor perimeter? So is this like outside of the building? I think is what we're talking about here.
Yeah, so if it was external, I would probably use something like XPS. Um, the reason why I'm hesitating is that I know that a lot of people in Cumbria will have stone-built buildings and will have earth floors and um, may not have DPCs. So perimeter insulation adds an added layer of problems, because if you use XPS, then you're shutting off one route of water getting out, and the potential is that then that stays in the floor, which uh, it's yeah.
Yeah, I mean, there are solutions. There are appropriate solutions for traditional buildings, but I think it depends on a lot of different factors, and it's best to talk to someone who is a specialist in insulating traditional buildings. In that, your specific example, I think you just have to. Yeah, we can't use a one size fits all for that
Yeah,
kind of thing.
yeah. I think that's definitely. I think that's definitely key with perimeter or floor insulation. It is, like I say, it's the most risky of all the measures, I would say.
Okay, so another question, we have a lower ground floor that is half underground. It's an old Victorian house. Could we use XPS on the walls here as it's tanked and therefore not breathable?
Uh, you might be better off if it's tanked. You might be better off using a foam back board. I can't believe I'm saying that. But if it's already impermeable, then uh, there's there's not as much need to keep it breathable. But again, it's risky if it's been tanked and it's been done well, and you know that the company that done it have done a really good job with it, then you shouldn't have too much issues. I think it's proving that they've done a good job of it is the first task. Um, it may mean stripping back the walls before you start and just having a good investigation to make sure that it's suitable. And in fact, I'd say that with any of the risky measures that I've mentioned, kind of floors or in cellars, that investigating first before deciding on a course of action is probably the best route.
Yeah, absolutely. Yes. So the next question, someone has, I have solid stone walls in a house built in 1890. Is it worth considering triple glazing in that example? And I suppose it might be worth asking that question if you're not insulating your walls or if you are insulating your walls. So perhaps it's a slightly different answer depending which way you're going.
I would always say that it's better to go triple than it is to go double. That and realize that there's a cost implication in that. That the cost for good quality triple is far more than it is for double glazing, but the benefits you get from it far outweigh using triple instead of going for double. That as long as you can stand the cost of it, it's a better option, even if you're not insulating the walls. Double glazing is even newly installed double glazing is not particularly efficient.
Yeah, I suppose the thing is that the direction of travel is that houses will eventually be insulated. Many houses, more homes will be insulated eventually. So at that point, if you're insulating your solid brick walls, then really triple glazing does make sense, because even triple glazing is going to be the weakest point in a well insulated wall.
Yeah. Yeah, and it may be that although when we're doing these measures, we're often thinking 10, 20, 30 years in advance. And although you may not be planning on insulating your walls right now, the next occupant may be, and they will probably appreciate a triple glazed window being in there before they start.
And I suppose the other thing is, if you're trying to work this out, is that this is why we do the Home Retrofit Planner energy model. So if you're going to spend quite a lot of money on insulation or windows or whatever, it might be worth looking at the energy model, because then you can actually model, it depends how much glazing you've got in your house to how much difference it's going to make, as well as part of the overall mixture of walls, windows, etc. So it might help in that case to actually look at an energy model that will give you a sense of how much difference does it make between double and triple? How much difference will it make if I don't insulate my walls versus if I do insulate my walls? And you can start to really understand what the choices are that you're making based on anticipated heat loss from the whole house in different scenarios. So I think Richard works with so that's your starting point, is often the Home Retrofit Planner energy model, and that's what we do here as well. So if you've got big plans, it's often worth thinking about getting some numbers on everything.
Yeah, absolutely.
I'm going to rattle through because we've got another 5 questions. It'd be brilliant to get through them. So one person has asked, any comment on foil insulation and ease of use for either suspended floor and for loft conversions? What do you think about foil insulation?
I'm on the fence with foil insulation. I know that building control and the manufacturers say that it's amazing, but I'm hesitant over its actual value. They say they say that it's wonder stuff and that you can get a good U value for a much thinner application, but I'm insulation isn't magic. It works in a specific way. It works by trapping air inside it. It's not the material, it's the air inside it that gets trapped, that stops the heat being conducted through it. So when someone says that their foil and thin insulation says that it's better than normal insulation, I'm slightly hesitant to. I don't use it, but yeah. I couldn't also say that it doesn't work. I know the things that do work.
So another common question that we get is, how do you find quality installers? And I think to some extent, Manchester, it's a city, it's, we've got the retrofit hub and that's pretty great. But in Cumbria, it's we're more like a donut. We're all sort of dotted around the edge of the mountains, so we've got a bigger challenge, I think, to find the right people. But do you want to give any hints and tips on how you might identify a quality installer?
Yeah, so obviously organizations like CAFS will be able to help. There might be a directory in places, but also once you've started going down the route of deciding on your retrofit and working out what elements you want to do and what approaches you want to take, suppliers and retailers can be good because they have knowledge of the materials that you want to use, but also they might have people on their books that they can recommend as well. It is difficult. There's more and more people are aware of it and doing it, but yeah, it's still a difficult
Yeah,
difficult aspect. Yeah.
yeah, and it's something that we are gradually building up a knowledge of some of the installers in the area, and we're not vetting them as such, but we are starting to build up some knowledge. So the people who come to us, home retrofit planner, and then follow through with further work with us, we are able often to match the kind of property that you're dealing with, and maybe some suitable installers that we know of. But it's a work in progress, I think, at the moment for us. And of course, you can talk to neighbours and things. If you know of a neighbour who's done something which has worked very well, that might be something you can ask them about, the quality of the workmanship and so on. But I would also say it's not just the installers, it's the quality of the design in doing the right things. It's no good if the guy puts the stuff on the wall beautifully if it's actually the wrong stuff.
Yeah.
So, get the right advice at the design and specification stage as well. And again, go to people who know, either talk to CAFs or talk to people who know about that and who are specialists, particularly if you've got traditional property, talk to someone who deals with traditional properties. Another question, how to deal with internal wall junctions going into solid walls when doing internal solid wall insulation in terms of minimizing the thermal bridges?
Okay, so that's probably too long, too big a question to answer right now. That is definitely one that is answered on a case by case basis. I think that uh, there are numerous ways you can deal with it, but it's all about the design and the specification and the materials you're using. So I think having someone that can advise you on that on your specific house is the best way to go with that.
Yeah. And we might have a few other answers like that. How best to insulate a disused chimney? Would you block it up at the top or the bottom or both? So what do you recommend people to do with chimneys?
So again, it's probably case by case. There's a few different methods, and it depends on where the chimney is. If it's internal, that it's not got on any external walls, you can be a bit more I don't know what the word is, not robust. You can be a bit more carefree with it. There's not so much worry, but if it's on an external wall, then you need to be careful with it. The blocking top or bottom or both, probably both, and probably filling it, but also making sure that because of what it was used for, because it's got soot and salts and all sorts of nasties inside it, you can end up with worse damp problems from chimneys than you can from a normal wall. The damp in it can leach the salts out to the surface, or and the soot inside can grab onto moisture and drag it in. So if you fill it, you could cause problems. If you don't fill it, you can cause problems. It's a tricky one. Again, probably case by case.
Yeah, yeah.
Maybe blocking it at the top, or but allowing it to be ventilated so that it dries out for a few years would be the first step, and then maybe filling it at a later date.
Or of course, go the whole hog and actually take it down,
Get rid of
but
it,
get
yeah.
proper structural engineering advice. I mean, I've had chimneys taken away completely, gave more space into the room. But you have to have the right. You can't just take it out. It
Yeah,
needs to be done with professional input from a structural engineer. But hey, if you've got rid of the chimney altogether, you're never going to have to, you've reduced some of those issues that might otherwise remain.
Yeah, absolutely.
I mean, not everyone can. Sometimes you can't change the look of the house, but in some cases you can. Okay, we've got a question about pests, insects, mice, and so on. Is that a problem with sheep's wool insulation?
No more of a problem in sheep's wool than any other insulation. Unfortunately, they love it. It gives them a perfect little nest to live in. So I think controlling that problem at source is probably the best way of doing it. A humane way of getting rid of them, like either in a trap or less humane with poison. But yeah, I don't think they put chemicals that stop animals biting it, but they still do. I mean, you still find little holes in all sorts of insulation, unfortunately.
Right. Okay. And we've got one last question here, so perfectly timed. What are your thoughts on externally insulating traditional thick slate or lime mortar walls? Or slate with lime mortar, obviously.
I think it'd be a shame, but then it's not my house.
Well, I think it depends. What I should say, here in Cumbria, I think the farmhouses were often built with a lime render on the walls originally, and the barns were built bare stone. So the house, it may be that we're talking about a farmhouse that already has
render on
a render on the walls. And sometimes one of the things we commonly find is that render might be replaced, not lime render, but it has at some point turned into a more modern type of render, and sometimes that holds water, so the walls are wet. So if you're in a stone house that's got a render on it and it's problematic, it's cracked, it's damp, etc., then in that case you're not going to change the appearance greatly by taking the old render off and, for example, insulating the walls or putting a lime-based product back on the outside. That might improve the building. But I suppose if it's bare stone, around here you've got more of a challenge because you're unlikely to be allowed to change the outside appearance.
Yeah, I think if all things being equal, if you're allowed to do it and there's no planning constraints, then I don't think there's any just hesitates. Like, I don't think there's any walls that you can't externally insulate. There's normally a solution you can find that will work as long as it's designed correctly and detailed correctly.
Yeah, and we're fortunate here in Cumbria because we do have architects who specialise on historic and traditional buildings and know a lot about the traditional products and the insulating versions of the traditional products, if you like. So the expertise is there. We've got good people doing the work and some very knowledgeable people doing the design, and so that you can get to some good end results. And there are good solutions, but not every builder takes the same approach, so it's worth.
Yeah, no, it's definitely doable, but with caveats, I think.
Yeah. Okay. Well, that's brilliant. So there's some really great questions there. So thank you everybody for all of your questions. I'm now going to share my screen to finish wrapping up. So I'll just bring that back. So yeah, thank you, Richard, for answering a very diverse range of questions and tackling a really big topic. And I hope everyone realizes, it takes a lot of experience. Richard, you've been doing this for quite a long time. You've been on quite a lot of courses. You've probably worked with designers, specifiers, and those kinds of people as well. So you've built up a real body of knowledge, and I think that's what leads to sort of successful retrofit. As a householder, you don't have to know all the answers, but you perhaps need to know some of the right questions to ask. You don't have to do your own new value calcs, but you can find the right people. So that's I think the main point. Don't feel got to know everything. So if your question hasn't been answered, or if you get other questions that come up, we've got a chance perhaps in the next webinar if you're thinking about ventilation. That's this coming Thursday. So there's a chance there, but also you can contact Kaths. We can answer over the phone a certain number of questions, either for our short advice calls with Cozy Homes or with a free retrofit consultation with the retrofit team. So do get in touch with us if you're interested. And then next week is our ventilation webinar. Do come along to that. Ventilation is incredibly important. It's often the sort of the Cinderella of the whole thing, I feel, but it is incredibly important. And the insulation, the airtightness, the ventilation work together. So do look at that. And we've got lots of recorded webinars there on YouTube as well from previous webinar sessions that we've done. So next steps, you can contact CAFS, join the next webinar. We are going to be sending out a follow-up email probably next week, certainly by Thursday next week, with the link to the recording of this webinar, so that you can listen to it again or look at the some of the links that we've put on there. Please do complete our survey. We're gathering feedback about how the webinars are. We're really interested to have your feedback on that. Get in touch with us if you want more advice. Look at our new lovely shop and buy some Christmas gift cards if that's going to be something you would find useful. Thank you to anyone who's made a donation. And finally, a really big thank you to Richard for speaking, and to everyone who's attended, and for all of your questions. So yes, we'll be sending the recording out probably in about a week's time, and we hope to see you again next week at the next webinar, or to be in touch at some point. So thank you, everyone. It's been great to have you, and see you another time.